Hi there, I promised I would work through the problems we had from the Red Book. Problem number 60. Series circuit has two voltage drops, 5.5 volts and 6.9 volts. What is the supply voltage? Here's what it looks like. We have a battery, that's our supply voltage. We have a resistor at some point. We have another resistor at some point. This one is consuming 5.50 volts. This one is consuming 6.90 volts, and it should be really obvious to us that when you add up these guys, you end up with the amount of voltage that the battery is giving out. So that would be, let's see, 6.4, 12.4, 13.4, because yeah, it's going to go to 6, and this is, no, I'm sorry, 12.4. I can't add today. 12.4 volts was your final answer there. Then we had number 61, I believe. Let me check the assignment. Yeah, 60 through 64. 61, parallel circuit has two branch currents, 3.45 amps and 1 amp. What is the current in the energy source? So what is it doing? We have a battery, which is our energy source. We have a branch of the circuit doing something. It's got some sort of resistance there. And we have 3.45 amps going that way. And we have another branch in which we have 1.00 amps. Now, as it comes back together, back to the battery, we've got that still 1.00 is going this way. Then when the two combine, it should be pretty obvious that our current I, the one going through the battery, is equal to current 1 plus current 2. So you're just adding the two up, so that's 4.45 amps for that one. Remember, in series circuits, voltage adds up. In parallel circuits, currents add up. Number 62, ammeter 1 in figure 2314 reads 0.20 amps. What's the total resistance and the current? Okay, for starters, let's draw the picture. 2314 was this one. Was that guy there. So we've got our battery. That's a shorthand of doing the battery notation. We have ammeter 1, the first place we read the current. We have a 22 ohm resistor up there. We have ammeter 2 reading the current at this point, going then through a 15 ohm resistor. Then we have ammeter 3, which is giving us whatever is going back up into the battery. Now, in addition to that, they have a voltage probe off to the side. Voltage probes have to be in parallel because they are testing the voltage here and the voltage here, and they're telling us what the potential difference is. Ammeters have to be in series because the current has to go through them for them to figure out how much current is going through that wire. Okay, let's go back to 62. Okay, so now with this going on, they said that ammeter 1 is reading 0.20 amps. What is the total resistance of the circuit? All right, so R equivalent. Sometimes I'll put it as the summation of R. It's all the same thing. This guy here is in series. That means this resistance plus this resistance. However hard it is to drink through this straw plus however hard it is to drink through that straw tells us how hard it is to drink the water through the straw system. Okay, you get the analogy, hopefully. So we're adding up the resistances because they're in series. That's easy. R1 plus R2, so 22 plus 15, so that's 37 ohms. Then for part B, what is the battery voltage? Okay, this gets now one thing we need to figure out, one thing we need to realize is that if I've got 0.20 amps going through there, since there's no place to branch off other than over here, and remember these voltage probes have a ton of resistance, so basically nothing goes through them. All right, so we have our total resistance. Our current of 0.20 amps is actually the same current that is found everywhere in this circuit because it is a series circuit. So we have the voltage of the battery is equal to the current going through the battery multiplied by the resistance, the equivalent resistance, which is the resistance of the whole circuit. And so we have 0.20 amps being multiplied by 37 ohms. So the voltage is 0.2 times 37. I guess I could have done that in my head. 7.4, and of course that is volts. It is really sloppy in my opinion how physics has a variable and a unit in the same chapter with the same letters. Okay, next, how much power is delivered to the 22 ohm resistor? All right, power. Power is equal to current times voltage. That's the simplest relationship we have, but we have not figured out what the voltage is that is being consumed by this resistor. We could very easily, by using V equals IR, well, we'll do that figuratively here. We will get rid of V by combining it with V equals IR, so we get the other power expression. Power is equal to current squared multiplied by resistance. Current going through the 22 ohm resistor is 0.20 amps. I have to square that, so it ends up being 0.04 multiplied by our 22 ohms. And so the power consumed, 0.2 times 0.2 times 22, is 0.88 watts. Right, not a whole lot. How much power is supplied by the battery? Okay, so for the battery, which is our last thing here, power is equal to current times voltage, and I'm trying to remember if we knew what the voltage of this battery was. Yes, we did. We figured it out up here. So we can say 0.20 amps multiplied by 7.4 volts. And so the power ends up being 7.4 times 0.2, 1.48 watts. This should make some sense. This is the power that is being given off by the battery, and some of it is being used by the 22 ohm resistor, and the rest of it is being used by the 15 ohm resistor. Okay, next problem. I gotta wake my phone back up and reorient things. Come on, wake up. 63, ammeter 2 in that same figure. Okay, so we got different values, so I'm going to redraw it again. Ammeter 2 in figure 2314 reads 0.50 amps. Okay, so we had our battery voltage, we had ammeter 1, we had our 22 ohm resistor, we had ammeter 2, which is the one that they just said has a reading of 0.50 amps. Then it goes through the 15 ohm resistor and comes back through ammeter 3 just to be triply redundant, and goes up there, and I'm not going to worry about the, well, fine. They mentioned what the voltage is, so I'll put the voltmeter back in there. Okay, so for 63, ammeter 2 reads 0.50 ohms. Find the voltage across the 22 ohm resistor. Oh, it's the one thing we didn't find last time. Now this time we have a current of 0.50 amps. So for A, the current across the 22 ohm resistor is equal to, well, V equals IR. So the voltage that is going, well, hold on a second. V equals IR. Let's just leave in that format. The voltage across the 22 ohm resistor is equal to the current going through the 22 ohm resistor multiplied by the resistance of the 22 ohm resistor, which is, of course, 22 ohms. So the voltage is 0.50 amps, being multiplied by 22 ohms. I don't need to grab a calculator this time. That's 11, and that's going to be volts. And then they would like to know what the voltage is across the 15 ohm resistor. All right, so voltage across the 15 ohm resistor is the current through the 15 ohm resistor multiplied by the resistance of the 15 ohm resistor, which is 0.50 amps multiplied by 15 ohms, so 7.5 volts for that guy. And then they would like to know what the battery voltage is. And again, a series situation, it adds up the voltages, so it is just the summation of these things. So V is equal to 11 volts plus 7 volts, 7.5 volts, so 18.5 volts in total. There's another way of doing this, that is to just go back to V equals IR, alternate method here. Voltage through the battery equals current through the battery multiplied by the equivalent resistance, and the current was 0.50 amps, and the equivalent resistance is the same as it was last time, which was 37 ohms, and 1/2 of 37 is 18.5 volts. It's all related to each other. There's at least a couple ways to do any problem anywhere. I'm going to stop the video at this point because this one's getting long, and then I'll film the rest of it.